Here we see now an overview of this project area with the DSM being processed at high resolution for this central part of the project area. So that is now an overview of this DSM, color-coded by elevation. Based on this DSM, the DSM-based orthophoto, a true orthophoto, can be created both in RGB and colored infrared in a synchronized way. Now we see the contribution mask to this DSM ortho. So every single color represents one input image for the orthomosaic. So based on the DSM and using the semantic image segmentation, the software can automatically filter to the DTM. So all objects that are above surface are detected, so like buildings and trees and cars and so on, and they can then be removed automatically from the DSM. These objects are shown with that mask here. Semantic image segmentation is also used to detect bridges. So if the purpose of the DTM is to create a DTM-based orthophoto, then it makes sense to include the bridges as we have seen them here highlighted in yellow. And then based on the DTM, a DTM orthomosaic can be created automatically by the software. And the seam lines, as we see them here, they try to follow the roads and avoid buildings and so on to not create any artifacts in the mosaic.
The DSM and the DTM are produced automatically in UltraMap. What if there are any specific requirements to the DSM DTM? Is there any way to edit the data?
Yes, there is an editor in UltraMap that allows you to modify the data as needed. So starting with the overview of the DSM, the user can do quality control of the entire dataset at full resolution, and then if some issue is detected, then tiles can be selected and they can be loaded into the editor for visualization in 3D. So that is the DSM now at full resolution of the 5 cm GSD of the input images. So for example, here we are doing an edit to get rid of some of the cars on this parking lot. So with this tool, this area is just smooth and these cars are gone. Another example for a modification of this data set is with this snow here. So also this can be just described with this polygon, and then the area is smoothed and it's gone. And when switching back and forth here, we see the effect on the projection of the images when changing height values. Similar tools are also available for the DTM, and for the DTM we also have a special feature. So if you need a certain area from the DSM in the DTM, maybe some terrain changes, building, bridge, whatever, then you can use this ground tool to highlight the area in the DSM that you want to have in the DTM. And then using this smoothing tool, the transition from DTM to the imported DSM area can be smoothed, and then you have this seamless integration of height values in the DTM. And based on this modified DSM and DTM, reprocessing of the orthomosaics can be done in a fully automated way by the software.